Okay, 4.1, day number 1, homework problem. Um, let's start with the range of this function. What is the lowest or the absolute minimum of this function? -5, absolute maximum. 4. Are there any gaps in between? No, so we can go straight from -5 to 4. Solve where f of x equals 4. Is that this? No, it's where does the function equal 4? Well, it equals 4 at -3. Okay, list the y-intercepts if there are any. How many y-intercepts? 1 at the point 0, -1. Right? Oh, this is a good one. Where is f of x greater than or equal to 0? That's asking me for x values at which the function is greater than or equal to 0. Well, here's where the function is greater than or equal to 0. So what x values would give me that? Closed. So wait. Is this odd, even, or neither? Neither. Right? Doesn't have y-axis symmetry or origin rotational symmetry. List the intervals where it's decreasing. Well, it'd be decreasing there as well as there. You don't want to close brackets on that, though, because at the endpoints, it's not technically decreasing there. It's decreasing after the endpoint, so you would have parentheses, not closed brackets. We would have, what is that, -3 to 0 and 2 to 3. Cool. Local minimums, how many are there? How many local minimums? There are actually 3 local minimums. Even the absolute max or absolute min is considered a local min, even though it's also the absolute min. So there are 3 local minimums. They are at -5, -5. What is that? 0, -1, and 3, 1. I've got a local min there, a local min there, and a local min there. The zeros of a function are where the function equals 0 at those 3 points. Correct. So where f of x equals 0s are your zeros. F of 0 is different than f of x equals 0, obviously. So. I've given you a head start here, so I'm going to go ahead and get started on each of the 3. You can keep working along with me. I'm going to work silently for those of you at home. All I'm going to do is plug in a -x to each of these functions and see if I get the original function out. If I get the original function out, which type is it? Even. If I get the opposite of the original function, it is what? Odd. And if neither of those 2 things happen, then it's neither. So here I go. Okay, looking at this is f of -x. Is this equivalent to the original? No. So it is not what? Even. So since f of -x is not equal to f of x, it is not even. Okay, so what I'm going to do next is I'm going to test to see if it's odd. So here's f of -x. I'm going to pull out a -1. When I pull out the -1, I get this. Is that equal to the opposite of the original? So do I have f of x right here? No. So f of -x is not equal to negative f of x. Therefore, it's not odd. So it has to be neither. You following? Okay, I pulled out a -1 because I want negative f of x. This thing in here, if it's f of x, I've got what I want. Second one, I plug in a negative x. What does that even power do to that? Turns it into a positive. Is that equivalent to the original? Yes. So g of negative x is equal to g of x. Therefore, this function is even. Okay, I always test even first, then I test odd, and if it's neither of those, then I know my answer as well. So the last one we're walking into, knowing that this is odd, and just a little trick to this, if you have a polynomial and the powers or the degrees of your polynomial are both odd, the function is odd. So what are the powers here? 1 and 3? Yep. It's going to be odd. I'm going to first test to make sure it's not even. That's just how I do it. Plug in my negative x. So h of negative x equals -7x, and that'll be plus 3x cubed. At this point, I know that h of negative x is not equal to h of x because those two are not equivalent. Now the next step, what am I going to do? Correct, I'm going to take out a -1. If I take that out, I get positive 7x minus 3x cubed. And this, is this f of x right here? Yeah, it is. So I know that h of negative x equals negative f of x, and therefore, oh, where'd the f come from? Therefore, it is odd. Cool. All right, you guys, when you get to